Today's notes are all about solving two-step inequalities. We are continuing to learn about inequalities. We've graphed them, we've written inequalities, we've solved one-step inequalities. Today we are solving two-step inequalities. Quick review here, and I would encourage you to write this down again, even though we already have. It is that important. But the one additional step that we need to know if we are solving inequalities is that if we multiply or divide both sides of an inequality by a negative number, we must flip the inequality. So again, if we multiply or divide both sides by a negative number, we must flip an inequality. And there's a lot of important parts to that. We must be multiplying and dividing. It has to be done to both sides of the inequality. It has to be not just with a negative number, but by a negative number. That is when we flip the inequality. Each of those pieces must be present in order to flip the inequality. So example 1, we are asked to solve each inequality and then to graph our solution. Number 1 is a review problem. It is a one-step inequality. We are given 2x is greater than negative 12. Solve and graph 2x is greater than negative 12. That means 2 times x, so we need to cancel out that multiplication. We cancel multiplication with division. We are going to divide both sides by 2. Negative 12 divided by 2 gives me negative 6. And then the question is, should we flip our inequality or not? We divided a negative number. We got a negative number. But remember, the important thing is, well, we need to multiply or divide. We divided both sides, yep, by a negative number. Notice here we didn't divide by a negative number. We divided by positive 2. We should not flip our inequality here. X is greater than negative 6 is our solution. It does ask us to graph it, so we probably should. That's not a very straight line. We need negative 6 on there, at least a couple points on each side. As we get bigger than negative 6, my numbers should be negative 5 and negative 4. Smaller than negative 6, I'm becoming more negative, negative 7, negative 8. Because we don't have the or equal to symbol, this should be an open circle. And I want the x's that are bigger than negative 6. I want my shading to be bigger than negative 6, which would be in this direction. Example 2 says 4 is less than 2/3 s minus 6. 4 is less than 2/3 s minus 6. In this case, we have both multiplication and subtraction. And notice, order of operations, we multiply before we subtract. So the first thing we need to undo is the last thing that happened. We need to undo that minus 6. We undo minus 6 by adding 6 to both sides. 4 and 6 make 10. I get 10 is less than 2/3 s. Over here I had 2x and I divided by 2. Here I have 2/3 s. So yes, we should divide by 2/3. But remember, dividing by a fraction is the same thing as multiplying by its reciprocal. It's going to be easiest to take care of that 2/3 by multiplying both sides by the reciprocal. We flip it. So instead of dividing by 2/3, I could also multiply by 3/2. And notice when we do that, 2 divided by 2 cancels, and 3 divided by 3 cancels. And on this side, I just get s. I multiplied both sides, but not by a negative number, so I'm not flipping my inequality around. 10 we can write as 10/1. 3 times 10 is 30. 2 times 1 is 2. And we get 15 is less than S. There's our solution. We graph our number line. 15's on there. A couple points on each side. I need an open circle. And notice the variable, which is what we shade in, is bigger than the 15. So I need to shade in over here. This one asks us to solve. It does not ask us to graph, so we don't need to worry about the graphing part here. Just solve. Find the solution to the inequality. Part A, we are given 7 plus 6A is greater than 19. 7 plus 6A is greater than 19. We have 6 times A, positive 6 times A, and then we are adding 7. So we need to undo that addition. We subtract 7 from both sides. 6A comes down. If that's a minus, don't forget to bring your minus sign down. 19 minus 7 is 12. We subtracted. We did something with a negative number on both sides, but I did not multiply or divide both sides. We do not flip our inequality. We leave it as is. 6 times A, we can divide both sides by 6. 12 divided by 6 gives us 2. Part B says negative 5k plus 12 is greater than or equal to 2. Negative 5k plus 12 is greater than or equal to 2. We need to undo that plus 12 first. We can subtract 12 from both sides. Two minus 12 is negative 10. I subtracted on both sides. I did not multiply or divide. We don't flip our inequality. Negative 5 times k. We divide both sides by negative 5. Negative divided by negative is positive. 10 divided by 5. And what matters is the number we divided both sides by. We divided both sides by negative 5. Yes, we flip our inequality this time. K is less than or equal to 2. Part C. Part C says 5 is less than x divided by negative 3 minus 6. 5 is less than x divided by negative 3 minus 6. Start by canceling out the minus 6. Add 6 to both sides. 5 and 6 make 11. Here we are dividing by negative 3. We undo division with multiplication. We are going to multiply by negative 3 on both sides. Negative 3 times 11 is negative 33. And we did multiply both sides by a negative, so we need to flip the inequality around. Negative 33 is greater than x. It's possible one like this might be multiple choice, and you do all this work, and none of the answer choices look exactly like this, because a lot of times they write the x first. So if one of the answer choices had the x first. Notice negative 33 is bigger. These two answers would be the same thing. So this is great. If it's a free response question, you can leave it like that. If it's multiple choice, understand that this and this are the same. Last couple examples are story problems. This one says, Sam works in the shipping department loading shipping crates with boxes. Each empty crate weighs 150 pounds. We are asked, what is the maximum number of boxes, each weighing 35 pounds, can Sam put in the crate if the total weight is to be no more than 350 pounds? If you're taking good notes there, I would write down a couple things. Empty crate weighs 150 pounds. We want to know the maximum number of boxes, each weighing 35 pounds. And the total weight is to be no more than 950 pounds. So we have an empty crate weighing 150 pounds. We're going to fill that crate with boxes. Each box weighs 35 pounds. We need to know how many boxes can we put in so that the total weight is no more than 950 pounds. So let's start with the basic part of the inequality. We want total weight to be no more than 950 pounds. So total weight, we're going to compare it to 950. If it's to be no more than 950 pounds, the 950 has to be bigger. The total weight has to be less than 950, or it could be equal to. It's okay for it to be equal to 950, but it couldn't be 951 or 952 and so on. So our total weight has to be less than or equal to 950 pounds. Now we need to fill in an expression for the total weight. So let's think about things that we have that weigh something. Well, we have an empty crate. It weighs 150 pounds, and we just have one of those. So we have that 150 pounds. That goes into the total weight. Plus, we're going to put some boxes in there. We don't know how many boxes, but each one weighs 35 pounds. So we're going to take 35 pounds times the number of boxes, and that would give us the weight of those boxes. So an expression for the total weight is going to be 150 pounds for the crate plus 35 pounds for each box. Has to be less than or equal to 950. Let's solve this inequality for B. So subtract 150 from both sides, giving me 35B is less than or equal to 800. And divide both sides by 35. And this would be a calculator problem. 800 divided by 35. Gives me 22.857. Question wants to know, what is the maximum number of boxes that we can put in? Well, we can't put in 22.857 boxes. We can put in 22 boxes, or we could put in 23 boxes, but we can't put in this fraction of a box. Notice the number of boxes that we put in has to be smaller than 22.857. So 23 boxes would weigh too much. So the maximum number of boxes that we can put in is 22. 22 boxes, because B has to be less than or equal to 22.857. One more. Last one says, suppose it costs $5 to enter a carnival. Each ride costs $1.25. You have $15 to spend at the carnival. Again, write down some of the problem in your notes. Just having answers with no problems isn't going to help you much. So it costs $5 to enter. Each ride costs $1.25. You have $15. We want to know the greatest number of rides. Again, the highlighted stuff is the minimum that I would put in my notes. It costs $5 to enter a carnival. Each ride is costing you $1.25. You have $15 to spend. What is the greatest number of rides you can go on? Like we did on the previous problem, let's start out with kind of just a words inequality. We have 15 total dollars to spend. So we want to compare money spent to 15. Think about for a minute which one of these needs to be bigger. Well, money spent can't be bigger than 15. I can't spend $16. I have to spend less than or equal to. I could spend all $15. Now, when we set up the expression for money spent, we want to think through what things cost us money. Well, it costs to get in the carnival. We have to pay $5 to get in. We only have to pay that one time, though, so just 5. Plus, each ride is costing us $1.25. So it's going to cost us $1.25 times the number of rides. I'm going to use R to represent the number of rides. And that needs to be less than or equal to 15. Now we can solve for R. Subtract 5 from both sides. I get 1.25. R is less than or equal to 10. Divide both sides by 1.25. And I get R is less than or equal to 8. Notice we never multiplied or divided both sides by a negative number, so we don't need to worry about flipping our inequality. R should be less than 8, or it could be equal to 8. So the greatest number of rides we could go on is 8 rides. That's a wrap for today's notes. We'll be back at it next time.